So now let's welcome our next speaker from France, Valérie, who is talking about the trends in building and ductwork airtightness in different countries.
Perfect. Yeah, well, I can reduce the size of the windows here. Just a second. There. Here. It will come. Yes, good. So hello, everybody. So I'm Valérie Leprince from Cerema in France. And I will talk to you about airtightness regulation in 12 different countries. So I first have to admit that I have absolutely not done this job. My colleague Nolwenn Urel has been presenting this. Something in Japanese appear in the middle. I'm sorry here. My colleague Nolwenn Urel has been preparing those slides. And she is the one that has performed this work on gathering information about airtightness in 12 different countries. Yes. So first of all, how this data has been collected. We have a very nice working group, which is the Tidevent Airtightness Association Committee that is facilitated by Tidevent and by INIVE. And within this group, we have set up a template for that every country to give the same kind of information regarding their regulation on airtightness on residential building and non-residential building. So for now, we have already 7 published papers here, and there are 5 more that are included in this presentation that are about to be published. So we have 12 papers that are included in this presentation. They are available on the AIVC website for free. So you can download it if you want to. So the countries that have been included in this survey are Belgium, Czech Republic, Estonia, France, Latvia, and Spain and Greece, for those where the VIP paper has been published. Greece, it's quite new, so this is why it has been switched down. And here we have also gathered information from China, Netherlands, Norway, Switzerland, and the US. And those are the other VIP from Australia, Germany, Japan, and UK that we are expecting to gather to also be able to compare what is going on in this country compared to the other countries. So what about building airtightness? First of all, when we talk about building airtightness, we found out that we do not all agree on which kind of indicator should be the good indicator for building airtightness. Most of countries do agree that 50 Pascal is a good value to define an indicator. It's usually the N50 that has been used for years, that is used in most regulation. But some other countries decided to do something else, like France, where we have an indicator at 4 Pascal and not 50 Pascal. And the Netherlands, we have an indicator at 10 Pascal rather than 50 Pascal also. However, more and more countries decide not to divide by the volume of the building, but to divide by the envelope area of the building, because in fact, this is where the leakage occurs. So it seems to make more sense to divide by the envelope area rather than dividing by the volume of the building. So more and more countries get indicator with the envelope area rather than the building volume. Now, what about requirements regarding airtightness? So I have had this discussion yesterday with Japanese people, and we concluded that France was much more strict than Japan regarding building airtightness. And this is probably the only thing that we are more strict than Japan in. So we do in France have a requirement, and every new residential building, even single houses, are tested at commissioning. And for multifamily building, we do sampling. So that means that we only test some of the dwelling in the building, and with sampling rules, because it's quite, okay, here I agree, it's impossible to test all dwelling everywhere. But yeah, every new residential building basically are tested with some requirements, which are in Q4 Pascal and not Q50 Pascal, but multiply by 2.5, and you will see the equivalent in N50. In Latvia, for example, there is requirement on building airtightness, but they do not need to test to justify it. So they should comply, but by default, they assume that they comply without testing. In Netherlands, this is a bit the same. They don't necessarily need to test. It's only above a certain area that they have to test the airtightness. In Belgium, and the opposite, they don't have a requirement, but most of buildings are tested because default value are so penalizing in the energy performance calculation, we'll come to that, that it's better to test than not testing, even without requirements. In Norway, also, almost all buildings are tested, both residential and non-residential buildings. In France, it's only for residential. In Spain, there is a requirement, but they can justify that they comply with the requirement only with some kind of calculation, depending on windows area and things like that. And in the US, well, in the US, it's always complicated because it depends on each code state. Yes, it is. Yeah. So some states do make a lot of tests, while some others do not. And yeah, California is probably one of the states that there is a more test performed in airtightness. No? Which one is the one? Okay, California is a state that doesn't test. So for airtightness, for people to realize that airtightness is important, it's important that it is well taken into account in the energy performance calculation of the regulation. If when you have a good airtightness, you don't have a reward at the end, you just don't care for airtightness. You need that it improve your global calculation of the performance of the building, that you will have afterward. So for example, in France and Czech Republic, this is a pressure code, a mass balance that is done at every time step, every hours, to calculate at every hours how much air going in and out, the leakages. So you really have the impact of airtightness depending on wind speed and depending on temperature difference at each time step. In most energy performance calculations that we have studied here, it is just a ratio. So you take N50 of 20 of 1, for example, multiply it by 0.07 in Norway, and you've got the infiltration flow rate, which is supposed to be the same at each time step. So this is a simplified method. What is important to promote the test is that once you include it in the energy performance calculation, to have a default value that is really a default value. So that means a very, very bad airtightness. So people will want to test to improve this value and then improve their energy performance calculation. If the default value is too good, nobody will test because, I mean, let's take the default value, it won't change anything in the end. So better to have a very, very high default value. Now, when there is requirements on building airtightness, the test has to be really, really reliable because it becomes mandatory to reach a certain value. So if you make the test, don't reach the value, and 2 days later, someone else come, make a test and reach the value, and 2 days later, someone else come and reach, no, it's not possible. The test, you need to have a very good reliability, you need to know its uncertainty, and the test need to be really reproducible. Okay, if multiple person does a test, they have to find the same result. Right now in Europe, we are using ISO 9972, which is a good standard for performing airtightness test, but is not precise enough to be able to perform tests that are reliable enough for now. So we have in most countries developed national guidelines to help perform the test. Also with ISO 9972, we have this problem that for very high building, we were discussing it just before, and for very high building, and when it's very windy, you cannot perform the test. And this is a problem because when the test is mandatory, you need to be able to perform the test, otherwise you cannot prove that you comply with the regulation. So this is why most countries have developed their own national guidelines that it would be good probably to include in ISO 9972. We'll talk about it just later after me. And also most countries have developed qualification tester schemes. So for example, in France, we have Calibat, which is the qualification of tester. To be able to perform a test in the context of the regulation, you need to be qualified, you need to have followed training and to have validated this training to show that you will make reliable tests. So how much tests are performed? So as I said, in France, it's mandatory for every residential building, so almost 100% of them are tested. It's not mandatory in Belgium, but they do test almost all of them because of the default value that is so penalizing. So this is two ways of making it happen. Around 15% 60%, sorry, in the US of building tested, and in most countries it's still around 10 to 25% of buildings that are tested in residential sector. In non-residential sector, I do agree that this is the most important, I think, but this is also the most difficult in terms of practicability. This probably exists. So in fact, there is still few buildings that are tested in non-residential building in the 12 countries that have been studied here. Also, if you put mandatory requirement on airtightness, you have to explain people how they can build airtight, because otherwise they will just make the building and in the end realize that it's not good and not know what to do apart from putting some mastics in the corner maybe. This doesn't work. This is not durable way of making airtightness, putting mastics in the corner. Again, we'll talk about it right after later. So most countries have also developed specific technical guidelines, technical details to explain how to make a building airtight. Now let's come to ductwork airtightness. It will go much faster because as much as we are in advance in building airtightness, in ductwork airtightness, we don't do a lot of things, unfortunately. So here there are only 10 countries that are included in this study because the Netherlands and Switzerland didn't have information to provide regarding ductwork airtightness. And what I just wanted to remind is that, in Europe, we test according to airtightness class. So there is class A, they used to have class A, B, C, D for airtightness, okay, D being the best one and A the worst one. And now it has changed a few years ago and they are airtightness class 1 to 7, but they are the other way around to mix every mind up. In the US, they have this fun unit that they use about a cubic foot minute per square foot at 25 Pascal. Yeah. And in China, it's simply the flow rate divided by the area of the ductwork. So in most countries, you see this all rates. There is no mandatory requirement on airtightness, on ductwork airtightness. In Spain, there is one, but it's not checked usually. So it's not implemented in real life. The problem is that ductwork airtightness is usually not well taken into account in the energy performance calculation. Again, as for building airtightness, if you don't have good things to make people test, if you don't promote it in the calculation, showing that it will save them energy in the end or improve the indoor air quality, it's just not made because it's useless. And so, for example, in the French case, we don't implement the impact on the fan power of ductwork airtightness test. So it means if the ductwork is leaky, technically you will have to have your fan run faster to compensate for the leakage. And this is not taken into account in the calculation. Only heat losses are taken into account in the calculation. It's better taken into account in the US, and this is why also there are more tests about ductwork airtightness in the US. Also because they do more than has the heating and cooling through the ventilation system. Airtightness test protocols, there are very few national protocols that have been developed, only in France and in the US actually. And so as you see here, it's very few buildings have their ductwork airtightness tested, apart from the US in residential building and Estonia for public building. Guidelines to build airtight ductwork. Again, this is very seldomly, well, some of, US, France, Estonia, and China have made standards to explain how to build tight ductwork. And that is it. Thank you for your attention. And I would like to really thank you first, my colleague Nolwenn, for preparing this presentation, and all the respondents of the VIPs that have allowed to do this comparison. Thank you very much.
Thank you very much. Any questions? So we have a couple of times can answer the questions if you have any. Yes?
Oh, will Canada answer VIP? I will send you the template. I would love to have Canadian information.
I'm wondering if you have like a label when the building is very airtight, like do you have a label like green building, energy efficient, energy starved building? Yeah.
Okay, so having an airtight building is not enough to get a label, but there is labels that do exist that impose to have, I know what to do here. Yes. That impose to have an airtight building in addition to other things. So for example, we've got the F-Energy label in France, and we need to have buildings that are 30% tighter than the regulation. There is the passive house label that is almost everywhere in Europe also, that correspond to, divided by 2, basically, the airtightness that we have in the regulation. And but it's not the only criteria.
Any more questions? Any questions online? Yeah.
So I'm wondering which country the test performance test is mandatory for new building. In France,
Yeah.
in your case, all buildings should be.
Every new residential building.
Every.
Yeah.
All of them.
Yes, you can do some sampling. If you've got if you have a big program, like for example, you make 10 houses exactly the same in the same neighborhood with the same constructor doing exactly the same, you can test only 3 out of the 10. But every program should be tested, actually.
Okay, thank you. And do you know the situation in UK, England?
In the UK, they test pretty much every building also.
Every,
yeah. Also, there is this allowing for sampling, but yeah, almost every program are tested.
Okay.
Same in Highland, I think. Yes.
And new builds are tested, but in a large housing
Sorry.
Thanks. So yeah, in Ireland, it's similar to France, where any new build is required to have an airtightness test of the building fabric, not the ductwork, as far as I'm aware. But in a new housing estate, it's a percentage of that. Now, I think the number has increased, but I'm not sure what it is. It was, I think, on the order of 10%. It could be up to about 25%, but I stand to be corrected on that. But it's a sample in a new housing estate.
Okay. Mr. Kravitz, yes.
One more question.
Here.
Thank you. You mentioned that every newly built residential building must be a test in the airtightness. So you must have some kind of regulation you have to comply.
Yeah.
But if you make some measurement, then some house exceeds that value, then what do you do?
Yes. So every new building have to comply with a certain level, at least in France. If they don't comply, they cannot have the paper attesting that the building is finished. So this is a problem for the insurance, because this is a construction insurance that's continue to run. As long as they don't have this paper, it's not the owner insurance that can start, because the building, the construction is not finished. In practice, what they do is that now, after we have been doing that for 10 years now. So most of the building comply or almost comply when they make the test at the end, because they know how to do it now. And if it's not complying, they just come with some mastics, silicone mastics, look for the leakage and the smoke, and with the smoke things, and they make some last minute reparation to be able to comply, because they are not that far away from the requirement.
So if the newly buildings do not comply the regulation, there would be some deep trouble. So there is some remedy to improve the airtightness in buildings, right?
Yeah. Well, I don't know if it would be big trouble, but this will be additional troubles that are easier to solve with mastics than trying to solve it with the insurance. Yeah.
Thank you very much.
Any more questions online? Oh, yep, we have two.
Speak slowly, James.
Thanks, Valerie. So just a question, have you noticed, is there any linkage between air tightness requirements and the type of ventilation that needs to be installed in these buildings? So for example, in Ireland, once we go below 3 meters cubed per hour per meter squared, we have to go to mechanical ventilation. So I don't know, is there any similar trends like that, or is it?
Okay, well, that depends on country. So this trend you are talking about is the same in the UK. It's exactly the same depending on the type of ventilation. They have a different level of air tightness to reach. Sorry, I will remove that. There. In Belgium, they have also different type of air tightness, but there is no recommendation regarding the kind of level of different kind of ventilation system, but no requirement.
There's a difference in the standard.
It's, yeah, but no requirement different in terms of air tightness. In France, 95% of new residential buildings have extract-only system with with humidity demand control ventilation. And those system, as was discussed before, really requires that you have a airtight building. Otherwise, it just extracts from the kitchen the air that is coming from the leakage in the kitchen. You have no chance that it will come through the bedroom, cross the corridor, and then go back in the kitchen. So you need for this building, for the ventilation system to work properly, to have her airtight houses. But there is no requirement depending on the kind of ventilation system. And Arnold, you have a question?
You have one question?
Yeah, but I'll keep it for the discussion. I see
Okay,
it's time
that's
for the
good.
next speaker.
Yeah, thanks. Okay, thank you very much. So now let's having the next presenter, who is in from the States, talking about air tightness testing of the large buildings.